The distance between point charges is increased by a factor of 4, the magnitude of the electrostatic force between them will be dash. Excuse me, what are these people asking? Since they are bringing about electric field, that's static electricity, Coulomb's law. We remember that Coulomb's law says that the force of attraction or repulsion is given by KQ1, Q2 all over R squared. Now, let's read the question again. If the distance between the mentioned distance, which is R, between point charges is increased by a factor of 4, the magnitude of the electrostatic force, which is this, between them will be dash. So they did not mention K, they did not mention the charges Q1 and Q2, that they did not give the values. So we assume that K, Q1, Q2, they are constant. So how that F is equals constant. Let me take C as a constant all over R squared. So if I cross multiply, I will have that C, the constant, is given by F R squared. So if you're a good physics student, if you have something like this, you should know that F1 R1 squared would definitely be F2 R2 what squared. Is that clear? So they say if the distance between charges is increased by a factor of 4, so that's the new distance R2 now is increased by a factor of 4. So R2, sorry, the old distance R1 is increased by a factor of 4, meaning that the new distance now is equals 4R1, 4 times the old distance. Is that clear? That's what they mean. The magnitude of the electrostatic force will be what? That's the new force of attraction or repulsion will be what? That's what they're looking for. So in this question, what they want us to find is F2. So I have F1 R1 squared is equals F2. Now R2 is given by 4R1. That 4R1 all what? Squared. So I have F1 R1 squared is equals F2. This multiplication law, what's 4 squared? That's 16, right? Then R1 what? Squared. Please, what are these people looking for? F2, right? So we divide both sides by 16 R1 squared over 16 R1 squared. So this cancels this. So I have that F2, the new electrostatic force, is given by, this will equally cancel this, is given by F1 all over 16. So what can I say? I will say that the new force is, sorry, the first force is now decreased by a factor of 16. So F2 is equals to 1 over 16 that of what? 1 over 16 that of F1. So F2, the new force, is equals 1 over 16 that of this. Or you say that the old force, F1, has been decreased by a factor of what? 16. Is that clear? So most times, excuse me, do you know that we can actually solve this without undergoing this? Without undergoing this, we can actually get our what? Answer. So knowing fully well that force and distance are what? Inversely proportional. Now, inverse variation tells us that when force is increasing, that distance is actually what? Decreasing. So if the distance between point charges is increased, so the distance is increased. Whenever distance is increased, force of attraction or repulsion should decrease, since that directly what? So since that inversely what? Proportional. Inverse variation. Is that clear? So for them to tell us that the distance is increased by a factor of 4, you should know that the force is meant to what? Decrease. So by a factor of 4, meaning that the distance now will now be, if you take 4 squared, that's 16. Now, without solving anything, you tell us that the force of attraction will be decreased by a factor of 16. Do you understand what I mean? Just know that force of attraction or repulsion is inversely proportional to distance. So when this one is decreasing, this one is increasing. When this one is increasing, this one is decreasing. I hope it's clear. Have a nice day. Like, comment, share, and follow Coulomb Academy. Bye bye.